Hi, welcome back to Unit 1. This is Section 2, Lesson 2, and the second video for this lesson. This is Ms. Clemens-Brenton, and in this video, we'll continue looking at the methods for determining perfect squares. In this video, we'll look specifically at prime factorization. Prime factorization is when a number is broken down into its prime factors. It can be used to determine whether or not a number is a perfect square, and if so, we can use it to determine the square root. We can use a factor tree. So for example, let's consider 36. We'll start with any two numbers that multiply to produce 36. So in this case, I'll start with 4 times 9. So I create branches off of 36 for both 4 and 9. So then I break each of these numbers down until I have only prime numbers. 4 breaks down into 2 times 2, and 9 breaks down into 3 times 3. This is as far as it'll go, because 2 and 3 are both prime numbers. A prime number, if you recall, is a number that's only divisible by 1 and itself. So now we create pairs with these factors. So we have a pair of 2's, and we have a pair of 3's. And if we can create pairs for all the factors, then the original number is a perfect square. So in this case, 36 is a perfect square because these factors all form pairs. Now if you remember, the square root is a number that multiplies by itself to produce the square. So I take one number from the pair of 2's, and I take one number from the pair of 3's, and I multiply those together to get the square root of 36. So 2 times 3 is 6, and 6 is the square root of 36. Let's look at another example. So if we consider 48, we can break 48 down into 6 times 8. 6 can be broken down further into 2 times 3. 8 can break down into 2 times 4. And 2, that can't be broken down any further. 3 can't be broken down any further. This 2 here can't be broken down. But 4 can be split into 2 times 2. So now all the numbers are broken down into prime factors. So now again we try to create pairs. So we have a pair of 2's, we have another pair of 2's, and then we have this 3 that's standing here all by itself. So because we can't create pairs for all the prime factors, this number 48 is not a perfect square. Example: use prime factorization to show if the number is a perfect square. If it is, state the square root. So let's take this first example, 324. So I can split that into any two numbers I want. So 324 is 3 times 108. So 3 can't be split up anymore, but 108 can split into 2 times 54. So that 3 I'll carry down, this 2 I'll carry down, and I know 54 can split into 9 times 6. So 3 doesn't go any further, 2 doesn't go any further, 9 can split into 3 times 3, and this 6 here can split into 3 times 2. So when I look at each of these numbers on the bottom, they can't split any further. So now I create pairs for all my numbers that are listed in the bottom here. So I have a pair of 3's, I have a pair of 2's, and I have another pair of 3's. So I take one number from each pair. So here's my pair of 3's. So I take one of those, I take one number from my pair of 2's, and I take one number from this pair of 3's, and I multiply those numbers together. So 3 times 2 is 6, 6 times 3 is 18. So because I was able to form pairs for all the prime factors that were listed, it was a perfect square, and then I take one number from each pair and multiply those together to get the square root. So 18 is the square root of 324. Let's try 156. So 156, I start with any two numbers that multiply to give me 156. So it'll be 3 times 52. 3 can't break down any further. 52 can split into 2 times 26. 3 will just go to 3. 2 carries down to 2. And 26 can split into 2 times 13. And I know 3 is a prime number, 2 is a prime number, and 13 is a prime number. So we have a pair of 2's, but this 3 here doesn't form a pair, and this 13 doesn't form a pair. So this, because not all pairs are formed, this is not a perfect square. Please proceed to the next video in this lesson.